So it looks like we're starting section 8.1, right triangle trigonometry, and word problems involving right triangle trigonometry. So let's draw a right triangle. It's a triangle with a 90-degree angle. So we'll put the 90-degree angle down here. We'll have another angle we'll call theta. That'll be our angle of reference. We'll call the adjacent side x, the opposite side y, and the hypotenuse z. So we're going to find the cosine, the sine, and the tangent functions. So, what is cosine? Well, the cosine is the adjacent over the hypotenuse, or in this case, x over z. The sine is the opposite of the hypotenuse, which in this case would be y over z. And the tangent would be the opposite over the adjacent, which in this case would be y over x. Excuse me. Then you have their reciprocal functions, the secant, the cosecant, excuse me, and the cotangent functions. So the secant in this case would be the hypotenuse over the adjacent, which would be z over x. The cosecant would be the hypotenuse of the opposite, which would be z over y. The cotangent is the reciprocal of the tangent, so that's adjacent over the opposite, which is x over y. So let's see if we can work some problems involving right triangles. So here's my first problem. Exercises. Here's number 1. Find the exact. It's my cat. Find the exact. Scratching up the chair. Find the exact value of the 6 trig functions of the angle theta. We're going to have a figure here. A right angle. Theta is actually going to be up here. And I'm going to have 5. I'm going to have the square root of 34 right here. So I guess I'll call this one x, since it's adjacent to theta, and square root of 34 I'll call z. So that means this unknown side here is going to be y. So before we even start finding the values of the 6 trig functions, the cosine, sine, tangent, secant, cosecant, cotangent, let's find y. Let's complete the triangle. In order to do that, we can use the Pythagorean theorem, right? We know that x squared plus y squared equals z squared, so we're going to have that 5 squared plus y squared equals the square root of 34 squared. So x squared plus y squared equals z squared. I'm going to have, 25 plus y squared equals 34. If I subtract 25 from both sides, I get y squared equals 34 minus 25. In other words, y squared equals 9. Now we're only going to take a positive root here. We're not going to do a negative root, just a positive root, because lengths, right, we're talking about lengths of a triangle. Lengths are only positive. So here our y is going to be the square root of 9, which is 3. So here we have 3. So once I have that, I can find the values of the 6 trig functions, the cosine, the sine, the tangent. Start with those basic 3. So the cosine, remember, if this is my angle of reference right here, theta. The cosine is going to be the adjacent over the hypotenuse. So it'll be 5 over root 34. And we actually want to multiply by root 34 over root 34 to get the radical out of the denominator, and we'll end up with here 5 root 34 over 34. For the sine, we're going to do, so the angle is theta, we're going to do the opposite over the hypotenuse. In other words, 3 over root 34. And here we're going to have to multiply by root 34 over root 34 to rationalize the denominator, get the radical out of the denominator. It's going to be, let's see, 3 root 34 over 34. And for the tangent, we're going to do your angle's theta, you're going to do the opposite over the adjacent. So that's going to be 3 over 5. All right, so we're going to do the reciprocals. We're going to do the secant, the cosecant, and the cotangent. So the secant is the reciprocal of the cosine. And I can actually use this version right here of the cosine. I'm going to reciprocate that version. I'll get root 34 over 5. Now I'm using that version so I can just get the radical in the top and the whole number in the bottom. So root 34 goes on top, the whole number 5 goes on the bottom. Let me box my answers in the green box. As far as the sine, if I reciprocate the sine, let's use this version, 3 over root 34, reciprocate that, and we're going to get root 34 over 5. For the cosecant, for the cotangent, we're reciprocating 3 over 5, we're going to get 5 over 3. So our answers here are in the green boxes. Cosine, sine, tangent, secant, cosecant, and cotangent. So, no calculator. But for the rest of this video, we'll probably use our calculator a lot. So make sure you have a calculator, and you want to make sure you set it into a mode of degrees mode. We don't want to use radians, we want to use degrees. So you may have to go into your mode and change from radians to degrees if it's not in degrees. Okay, so working some problems. Let's say we have a triangle, and we have the following given. If b is equal to 5, and little c is equal to 13, find little a, find big A, and big B. I'm going to draw a figure. So here we have big A, big B, these are angles. Here's a 90-degree angle down here in the right-hand corner. That's actually going to be big C, but I'm not going to label it. We'll have little c, little a, and little b. Now what do we know? We know little b is 5, little c is 13. That's what's known. So the unknowns here are little a, big A, and big B. Those are the things we have to find. So I think the easiest thing to find here is a little a first. Let's find little a, and we can use the Pythagorean theorem for that. So we know that a squared, what color am I going to use for that? I just use black. A squared plus b squared, 5 squared, equals c squared, 13 squared. So a squared plus 25 equals 13 squared is 169. If I subtract 25 from both sides, I get 169 minus 25 on the right. I get a squared equals 144, and I take the square root of 144. Just the positive root, right? We only want the positive root because we're talking about lengths. Lengths are only positive, so a is 12 here. So I got a. Let's find capital A. Capital A, that's an angle right here. So there are many ways you could find capital A. I'm going to actually use, so if this is my reference angle here, capital A, I'm going to use the adjacent over the hypotenuse, which is the sine function. So let me do that. I'm going to find capital A and say, sorry, the cosine, right? The cosine is the adjacent over the hypotenuse. Cosine of capital A is 5 over 13. 5 over 13, that's adjacent over the hypotenuse. Now, if I wanted to find A to an approximate value, so I drop the cosine here on the left side, I'm going to take it to the right, it becomes the cosine inverse. So A is going to be the cosine inverse of 5 over 13. Now, we can't find that value exactly analytically, but we'll estimate in the calculator. So we're going to turn on our calculators and we're going to type the following. I'm going to clear my calculator if I can. I'm going to press, so I have a second button, so it looks something like this. Looks something like second. And then cosine. So I enter that, second cosine. And then I'm going to press 5 divided by 13, and then I press enter. It's kind of the sequence of buttons I press in my calculator. Second cosine. So second cosine is the cosine inverse. So when you actually plug it in your calculator, at least mine looks something like this. So it actually looks like, in my calculator, it looks like, I'll put it in black, it looks like the cosine inverse 5 divided by 13, and I close my parentheses, and then I press enter. So let me try that. Second cosine, so I get a cosine inverse 5 divided by 13, close the parentheses, and enter, and I get around 67 point, rounding it. I'm going to round this to the nearest degree, 67.4 degrees. So if you're getting some other number besides 67.38013505, you're getting something else besides 67.4 roughly, probably means you're in radians mode and you want to go back into the mode and change it from radians to degrees and then try that again. You get 67.4. So we got A. Now let's find capital B. So this is 67.4, let's say. Now to find B, we can use the fact that the triangle's angles all add up to 180 degrees. So we already know one of the angles here is 90, right? This one is 90 right here. So I'm going to have 90 degrees plus 67.4 degrees plus B, that's the unknown, right, is equal to 180. So we're going to take 90 plus 67.4. I'm going to get 157.4. Plus B equals 180. So B, I'm going to subtract 157.4 from both sides. I'm going to get 180 minus 157.4 is B. So B is approximately this. Why am I saying approximately? Well, I rounded off earlier the 67.4, so this is approximate as well. 157.4, 180 minus 157, that's 22.6. So B should be about 22.6. So these are approximations to the nearest degree. I think the nearest degree is fine. All right, so we completed that triangle. We got all the sides, we got all the angles. Let's do another completing triangle problem. A little different situation. What do we have? We have the following. If A is 8, and capital A, that's an angle, is 50 degrees, let's find little b, little c, and big B. And we're going to have a figure here. So here's big B, big A, and this 90-degree corner, that's going to be big C, actually. I'm not going to write it, but understand that's big C down there in the bottom right corner. We got little c, little a, little b. So what do we know? We know little a is 8, big A is 50. That's all we know. So we got to find the other things. We got to find, what do we got to find? We got to find big B. We got to find little b. And we got to find little c. So I think the easiest thing here to find first is big B. You can just use the fact that the angles all have to add up to 180. So you got two of the angles, right? You got one is 90 here, one is 50, and add that to B, and they all add up to 180. So I got 90 degrees plus A, 50 degrees, plus B, that's the unknown. That's going to all add up to 180. So 90 plus 50 is 140. So 140 plus B, that's going to be equal to 180. And then I subtract 140 from both sides. I get B, sorry, wrong color. B is equal to 180 minus 140. So B is actually 40 degrees. That's the easiest thing to find. 40 degrees exactly. So what do we want to find next? You can find little b, you can find little c. I'm going to find little b. If I'm finding little b, I could use maybe like a sine or a cosine or a tangent, maybe. Well, no, you couldn't use a tangent. You couldn't use a tangent because you don't know the height. No, sorry, you couldn't use a sine or a cosine. You can't use a sine or a cosine because they involve hypotenuse, and we don't know the hypotenuse yet. So, and we certainly can't use the Pythagorean theorem because we only know one side. We don't know two sides. You need at least two sides to use the Pythagorean theorem. We could use the tangent. Use the tangent. I'm going to take the tangent of 40 degrees. Remember, the tangent is the opposite over the adjacent. So opposite of 40 is B, and the adjacent is A, which is 8. So the tangent of 40 is the opposite, B, over the adjacent 8. So if I kind of cross multiply here, that means I'm going to bring the 8 up here in front of the tangent. I'm going to get 8 tangent of 40 degrees equals B. And if I calculate in the calculator, I'm going to do kind of the sequence of buttons I would press. I'd press like 8 multiplied tangent, then 40. And then enter. And you have to make sure this is in degree mode. So if you already had it in degree mode, you don't have to change it to degree mode. It's already in there. So this will be something like, in the calculator, it'll look like 8 times tangent of 40. And you press enter. So you get, let's see, 8 times tangent 40. I'm actually going to close parentheses. You really don't need to close the parentheses. I'm going to do it. I got about 6.7. I'm going to go more decimal places. I'm going to go 6.71. So for lengths, I'm going to go 2 decimal places. For angles, I'm going to go just 1, but for lengths, I'm going to go 2. If you want to find C next, so we got 6.71 here. So we got 2 sides, right? We got A, we got B. Then we can find C using the Pythagorean theorem. So if you want to find C, you just use the Pythagorean theorem. We got, let's see, 8 squared plus 6.71 squared equals C squared. That's going to give us, let's see, 8 squared is 64 plus 6.71 squared. I add those together, I get 109. 109.0241 is equal to c squared, and then I take the square root of 109.0241. Let's see, what is that to square root? 109.0241. I get about 10.44. About. Remember, this is an estimate. So I completed my triangle, I found all the sides. Now, if you want to get more accurate with your C, you can round the B off to more decimal places. If you round B off to more decimal places, like 4 or 5 or 6 decimal places, that'll allow your C to be more accurate using the Pythagorean theorem. But I'll generally just go to 2 decimal places for lengths, and for angles, just 1 decimal place. All right, so there is a start to right triangle trigonometry.